Hi, I'm Bob. Welcome back to the solutions to the exercises for the textbook Microeconomics Theory and Applications with Calculus, the 5th edition by Professor Jeffrey Perloff. We will finish solving the last 3 problems for the Sequential Dynamic Games section today. Here's exercise 3.11. Before entry, the incumbent earns a monopoly profit of $10 million. If entry occurs, the incumbent and the entrant each earn the duopoly profit of $3 million. Suppose that the incumbent can induce the government to require all firms to install pollution control devices that cost each firm $4 million. So the game tree. Should the incumbent urge the government to require pollution control devices? Why or why not? It is a sequential dynamic game with 2 stages. The incumbent monopoly moves first. We draw the game tree according to the description in the exercise and use the backward induction approach to find the subgame perfect Nash equilibrium. We first determine the potential entrance response in the second stage to each possible action by the incumbent. Given that the incumbent urges the government to require pollution control devices, the potential entrant gets -1 if it enters the market, but 0 if it does not. The potential entrant's best response is not to enter the market. We underline its profit 0 and add an arrow on the path. Given that the incumbent monopoly does not urge the pollution control requirement, the potential entrant's best response is to enter the market because it brings a higher payoff. We underline its profit 3 and add an arrow on the path. Next, we figure out the incumbent's decision in the first stage, given its rivals' responses. If the incumbent urges the government to require pollution control devices, it knows its rival will not enter the market and it will earn 6. If it does not urge the use of pollution control devices, it knows its rival will enter the market and it will earn 3. The incumbent is better off urging the government. We underline its profit 6 and add an arrow on the path. The subgame perfect Nash equilibrium is that, in the first stage, the incumbent monopoly urges the government. In the second stage, the potential entrant does not enter the market if there is a requirement, but enters the market without the requirement. Recall that a strategy is a plan that specifies a full set of actions conditional on its rivals' possible actions. So the potential entrance strategy in the second stage should be stated as above. The equilibrium path is the path with 2 arrows. The incumbent monopoly first urges the government to require pollution control devices, and then the potential entrant chooses not to enter the market. The outcome of the game is that the incumbent gets $6 million and its rival gets 0. The incumbent monopoly should urge the pollution control policy, although it will raise its cost. That is because it discourages potential rivals from entering the market. Without the rival, the incumbent monopoly can earn a higher profit than that with a rival in the market. Let's answer exercise 3.12. Due to learning by doing, the more that an incumbent firm produces in the first period, the lower its marginal cost in the second period. If a potential entrant expects the incumbent to produce a large quantity, it does not enter. Draw a game tree to illustrate why an incumbent would produce more in the first period than the single period profit maximizing level. Now change the payoffs in the tree to show a situation in which the firm does not increase production in the first period. It is a sequential dynamic game with two stages. The incumbent moves first. We draw the game tree and use the backward induction approach to find the subgame perfect Nash equilibrium. We can devise some profits for the incumbent and the potential entrant in the four combinations of the strategies. We first determine the potential entrant's response in the second stage to each of the incumbent's possible actions. Given that the incumbent produces a large quantity, the potential entrant gets -1 if it enters the market, but 0 if it does not. The potential entrant's best response is not to enter the market. We underlie its profit 0 and add an arrow on the path. Given that the incumbent produces the profit maximizing quantity, the potential entrant's best response is to enter the market because it brings a higher profit. We underlie its payoff of 1 and add an arrow on the path. Next, we figure out the incumbent's decision in the first stage, given its rivals' responses. If the incumbent produces a large quantity, it knows its rival will not enter the market, and it will earn 6. If the incumbent produces the profit maximizing level, it knows its rival will enter the market, and it will earn 3. The incumbent is better off making a large quantity. We underlie its profit 6 and add an arrow on the path. We can circle the outcome with 2 profits underlined. It is the outcome of the dynamic game. The subgame perfect Nash equilibrium is that in the first stage, the incumbent produces a large quantity. In the second stage, the potential entrant does not enter the market if the incumbent produces a large quantity, but enters the market if the incumbent produces the profit maximizing level. Recall that a strategy is a plan that specifies a full set of actions conditional on its rival's possible actions. So the potential entrant's strategy in the second stage should be stated as above. The equilibrium path is the path with 2 arrows. The incumbent first produces a large quantity, and then the potential entrant chooses not to enter the market. The outcome of the game is that the incumbent gets $6 million and the potential entrant gets 0. The incumbent produces more than the profit maximizing level in the first stage to discourage potential rivals from entering the market. However, if we alter the profit, then the Nash equilibrium may change. Suppose that the profit the potential entrant will earn is positive if it enters the market, given that the incumbent produces a large quantity. In that case, the potential entrant's best response to the incumbent producing a large quantity is to enter the market. The potential entrant's strategy in the second stage is to enter the market, no matter what level the incumbent produces. In the first stage, the incumbent monopoly will choose the profit maximizing level because it gives a higher profit of 3 instead of 2. The equilibrium path becomes that the incumbent first produces the profit maximizing level, and then the potential entrant enters the market. The outcome of the game becomes that the incumbent earns $3 million, and its rival gets $1 million. Let's go to exercise 3.13. In 2007, Italy announced that an Italian journalist who had been held hostage for 17 days by the Taliban in Afghanistan had been ransomed for 5 Taliban prisoners. Governments in many nations denounced the act as a bad idea because it rewarded terrorism, encouraged more abductions, used an extensive form game tree to analyze the basic arguments. Can you draw any hard and fast conclusions about whether the Italians' actions were a good or bad idea? It is a sequential dynamic game with 2 stages. Taliban moves first. It decides whether to abduct. The Italian government moves in the second stage, choosing whether to pay the ransom. We draw the game tree and use the backward induction approach to find the subgame perfect Nash equilibrium. We first determine the government's response in the second stage to each possible action by the Taliban. Given that the Taliban kidnaps the journalist, the government gets 5 if it pays the ransom, but 0 if not. The government's best response is to pay the ransom. We underline its payoff 5 and add an arrow on the path. Given that the Taliban does not abduct, the government's best response is not to ransom. We underline its payoff 0 and add an arrow on the path. Next, we figure out the Taliban's decision in the first stage, given the Italian government's responses. If the Taliban engages in abduction, it knows the government will pay the ransom and it will earn 10. If the Taliban does not kidnap, it knows it will get 0. The Taliban is better off kidnapping. We underline its payoff 10 and add an arrow on the path. We then circle the outcome with 2 payoffs underlined. It is the outcome of this dynamic game. The subgame perfect Nash equilibrium path is the path with 2 arrows. The Taliban first kidnaps the journalist, and then the government pays the ransom. The outcome of the game is that the Taliban gets 10 and the government gets 5. It encourages kidnapping, but it is the Nash equilibrium, and both players have no incentive to deviate from it, unless the government can make a credible commitment that it will never pay the ransom. One possibility is that the government cares about the future effects of its actions. It considers the negative influence the ransom may cause, such as leading to more kidnappings in the future, and the positive impact of not paying the ransom, like reducing future kidnappings. In that case, the payoff of not paying the ransom changes from 0 to a positive number. If it is greater than 5 in our example, then the government's strategy in the second stage is that it will never pay the ransom, no matter what the Taliban chooses. The subgame perfect Nash equilibrium path will be the Taliban does not kidnap and the government does not pay the ransom. The Taliban will not engage in abduction because it is not in its best interest to do that. Thank you very much for solving all the exercises in this section. See you soon. Goodbye. Thank you for watching this video and subscribing to my YouTube channel. See you next time.